Picking up where we left off, it says, however, there is a simpler method to determining if two fractions are equivalent using the cross products method. Now we have 16 over 40 is equal to 10 over 25. Now, to use the cross product method, we will take 16 times 25 and 40 times 10. Now, of course, these arrows are pointing a little differently, but just take the top of the first times the bottom of the second, and that will give you this first value here. I see it broke the line here. And then we would take the bottom of the first times the top of the second, and it would give us this second value here. Now, because remember, multiplication is cumulative, so if you put the 16 first or the 25 first, it's still going to give you the same answer. So now we multiply. 25 times 16 is 400. 40 times 10 is 400. That means that these fractions are equivalent. Now note, if the cross products are not equal, the fractions are not equivalent. So let's go down here and take a look. So let's do this again. Determine whether the following fractions are equivalent. So we would take 4 times 12. 4 times 12. For some reason this 4 isn't working too good, but so we'll have 4 times 12. Okay, I corrected that 4. So we have 4 times 12, which would give us 48. And that is supposed to be equal to, now we would take this 6 times 8. So we have 6 times 8. Now 6 times 8 is also 48. So your answer here is yes. Okay, now we do the same thing here. We would take 9 times 48 is equal to 12 times 27. Now we could take 9 times 48 to the side. We could put the 48 first and make it a little easier. 8 times 9 is 72, carry a 7. 9 times 4 is 36, plus 7 is 43. So this will give you 432. Now we do 12 times 27. We could put the 27 first. 2 times 7 is 14, carry a 1. 2 times 2 is 4, plus 1 is 5. Write down your 0. 1 times 7 is 7. 1 times 2 is 2. So we add these. We have 4, we have 12, so it's 324. If you notice, they are not equal to each other, so your answer is no. And you can also draw a line through here signifying they're not equal. Now, we scroll on down here to section D. It says solving problems by writing fractions in simplest form. There are many real-life problems that can be solved by writing fractions. To make answers clearer, these fractions should be written in simplest form. Number 1, there are 58 national parks in the United States. 6 of these are located in Washington State. What fraction of the United States national parks can be found in Washington State? First of all, we need to put down how many parks that we have in the whole United States, which is 58. And then in the problem here, it tells us we have 6 in Washington State. Now it tells us to write the fraction in simplest form. Now the prime factorization of 6, we know is 2 and 3. Now with 58, that breaks down to 2 times 29. 2 is prime, and also 29 is prime. So we'll have 2 times 29. These sets of 2s simplify out, and you're left with 3 over 29, which is your final answer. Now we come to number 2. It says 6 weeks of the 16-week semester have been completed. What fraction of the semester is over? Okay, so now this is what we would do. First of all, we have 16 weeks in this semester here. Now, they tell us what fraction of the semester is over. So, if 6 weeks are done, then that means 6 out of the 16 are done. So now we simplify. Prime factorization of 6 is 2 and 3, and we did the prime factorization of 16, which is 4 2's. Now these 2 simplify out, and you add 3 over 8. Now it says here, how many weeks of the semester are left? Now remember, we start off with 16 weeks, and 6 weeks are completed. So 16 minus 6 is 10. So it's 10 weeks left. Now it says here, what fraction of the semester is left? So what we would do is the semester, we know it's 16 weeks in the semester, and we add 10 weeks left. So we add 10 over 16. Prime factorization of 10 is 2 times 5. Prime factorization of 16, we know it's 4 2's. These 2's simplify out, and you will have 5/8. Now we go to number 3. It says getting an associate's degree requires earning at least 60 college credits. The chart below shows the number of credits Anne earned last year, her first year of college. Okay, what fraction of the credits she needs for her associate's degree did she earn during the fall semester? Now, first of all, the total amount of credits she needs is 60. And what she earned in the fall was 12. So now we need to take the prime factorization of 12 and 60. Now we can start off here. I'll do 12 over here. It's 2 and 6, and then 2 and 3, because we know 2 is prime, and also this 3 is prime. So the prime factorization of 12 is 2 times 2 times 3. Now we want to do the prime factorization of 60. Now I'll write 60 over here. 60 is 2 times 30. 2 is prime, 30 is not. 30 breaks down to 5 times 6. 5 is prime, 6 is not. And 6 breaks down to 2 times 3. So 2 and 3 is prime. So our prime factorization here is, we add 2 2's, a 3, and also a 5. So now we simplify. We add 2 sets of 2's and 1 set of 3's. Now since everything's simplified from the numerator, that's 1. And your denominator is what's ever left in your denominator. So it's 1/5. Now we go to B. What fraction of the credits she needs for her associate's degree did she earn during her first year? So we need the total of fall, winter, and spring. When we add this together, this gives us 36. So our denominator is still 60, and our numerator is 36. Now we already found the prime factorization of 60, which was 2 2's, a 3, and a 5. So now let's find the prime factorization of 36. You got 2 times 18, 2 times 9, and also 3 times 3. So we had 2 2's and 2 3's. Okay, so now we simplify out what they have in common. We had 2 sets of 2's in common and 1 set of 3's in common. So our final answer here is 3/5. Now it says, how many credits does she need to earn? How many credits does she still need to earn? So we know it's 60 that it takes her to graduate. She's already earned 36. So that leaves 24. So that's 24 credits. So that takes care of C, is 24 credits left. Now we go to D. What fraction of the credits she needs for her associate's degree does she still need to earn? So we know it's out of 60, and it's 24 out of 60. Now we already did 60. It's 2 2's, a 3, and a 5. Now we have to find the prime factorization of 24. We had 2 and 12, 2 and 6, and then 2 and 3. So now we have 1, 2, 3 2's, and 1 3. So now we simplify out what they have in common. We had 2 sets of 2's, 1 set of 3's. So your final answer here is 2/5. Now we come to multiplying fractions. Now to make this simple, in order for you to multiply fractions, if you have fractions multiplied to each other, you just multiply all the values that are on the top or the numerator and all the values on the bottom. So A times C, B times D. Now let's watch this. Let's try number 1 here. Using this method, we multiply our numerator. 3 times 5 is 15. Our denominator, 8 times 7 is 56. And I would just tell you this here. They have nothing in common, but we'll see that a little later. So now we do this here. 1 times 1 is 1. Negative 3 times negative 6 is positive 18. Now we come here to number 3. Now number 3, I want to show you this method here because you see the method for multiplying fractions. You have the top times top, or we call it numerator times numerator, and then the bottom times the bottom, or denominator times denominator. Okay, now first of all, with this fraction here, a positive times a negative, we know we're going to have a negative answer. Now this is what I would suggest you do. If we're doing all multiplication, I would suggest that you take the prime factorization of this number and the number it's being multiplied by. So the prime factorization of 6 is 2 times 3, and the prime factorization of 5, because we put the negative out here, is just 5. So that would be our numerator. Our denominator, the prime factorization of 55, we could go to the side. That's 5 times 11. And the prime factorization of 8, we can still go to the side. That's 2 times 4, and then 2 times 2. So we had 3 2's here. So we could write those 3 2's here. Now all we have to do is simplify. They have one set of 5's in common and also one set of 2's in common. So our answer here would be negative 3 in our numerator, and our denominator would be 44. So it would be negative 3 over 44. Now, you know what? Let me rewrite this because I don't like that slash going through that 4. So it's negative 3 over 44. Okay, so that looks a lot better. Okay, now, again, don't you think it would have taken you a longer time if you would have said 6 times negative 5, which would have been negative 30, and 55 times 8, which would be 440? I think it might have would have took a little longer time if you would have tried to simplify this instead of taking a prime factorization here. So what I'm going to do in number 4, I'm going to do it both ways. So let's go and multiply it across. 4 times 3 is 12, and 15 times 8 is 120. Now we have to determine what does 12 and 120 have in common, or we could do the prime factorization here at the end. 12 breaks down to 2 times 2 times 3, and 120 breaks down, and since we never did 120, I'm going to write 120 out. So you have 120, we could do 2 times 60. 60 breaks down to 2 times 30, and we've done 30 before. We know 30 breaks down, well, we could do this 5 times 6, and 6 breaks down to 2 times 3. So we have 1, 2, 3 2's, 1 3, and 1 5. So we had 2 sets of 2's that simplify out, and 1 set of 3's. So this would give us 1/10. Now this is one way of doing it. Now I'm going to show you the other way of doing it as well. So I had to create a little bit more space. So what I want to do now is I want to go back and do it the way how we did this first, where we did the prime factorization. So the prime factorization of 4 is 2 times 2, and 3 is already prime. All over the prime factorization of 15 is 3 times 5. And we've done the prime factorization of 8 before, which is 3 2's. Now if you notice here, we have 2 sets of 2's that simplify out, and 1 set of 3's that simplify out. And that still gives us 1/10. So either method is fine. Now, of course, I'm only going to use one method, which is this second method here. Okay, so now we go here to number 5. Now, 7 is already prime. 5 is already prime. We'll write our x. Now, whenever we're dealing with the algebraic fraction multiplying, we could do it the same way we did in section, the last section. We could take the prime factorization of the numbers first, then the variables. So the prime factorization of 10 is 2 and 5. Prime factorization of 8 we know is 3 2's. And the prime factorization of x squared is x times x.